So welcome back. We're still in section 5.2 on the inverse matrix. We're going to start with a little remark. If you remember in the previous video, we had finished off with an example where given a matrix A, we were asked to show that a matrix B was the inverse of A. And we did that by showing that AB equals I and BA equals I. In other words, both multiplications. So the remark that I'm going to make here is that it can be proven, and this will be maybe not very satisfying because we're not going to prove it right now, but it can be proven that in the case of n by n matrices, if AB equals I, then necessarily BA is equal to I also. Okay, so the remark is that from now on, you can assume this to be true and you can show just one of the two multiplications. Okay, so either AB equals I or BA equals I. You don't need to show both. Okay, so a little quick example of that. Actually, let me just notice that this should have been down here. So we're going to get to that in a second. That's about the formula. But just a quick example of what we were just saying. So example, if you're given a matrix, let's say A equals 1, 2, 1, 0, and asked to show that matrix B, which I'll just magically come up with, and we'll see in a second how I came up with this matrix, but show that B is the inverse of A. The inverse of A. In other words, another way of saying that is to say that B equals A inverse. Remember the notation? And so what the remark says is that we don't need to show both products. We can just do one of the two. So we'll do 1, 2, 1, 0 times matrix B, 0, 1, 1 half minus a half. And by now we're sort of old pros at matrix multiplication. So row times column, and that's going to give us the first entry. So row times column gives us this entry. And that's 1 times 0 plus 2 times a half. So that's simply equal to 1. And then first row, second column, same thing, right? So 1 times 1, 2 times minus a half, so 1 minus 1, 0. And if we complete the multiplication by doing second row, first column, 0 plus 0, and second row, second column, 1 plus 0, so 1. And that's exactly what we expected. And so AB equals I, which means we can conclude that B is equal to A inverse. Okay. In other words, we don't need to show both multiplications, AB equals I and BA equals I, but just one of the two. Okay. So how did I come up with this matrix B? Well, it's not magic, it's a formula. And that's what the remark says here. For 2 by 2 matrices, we have the following rule or the following formula. So let's scroll down to that. So it's given here in the form of a theorem. And what the theorem says simply is that a 2 by 2 matrix, A, B, C, D, is invertible if and only if AD minus BC is not 0. So these values, AD, BC, come from the matrix. So AD minus BC is just cross-multiplying and subtracting. And if that number is not 0, then we can use the following formula for the inverse. 1 over AD minus BC, so we see why it needs to be non-zero. It's in the denominator. And the matrix that we have next to that scalar is obtained from A, as you can see by interchanging the positions of A and D, whereas B and C don't move, but they take on the opposite sign. And so that's going to be the formula for a 2 by 2 matrix. Okay, we're not going to prove this right away. As it says here, we're going to do this in the exercise sheets. So you'll be doing this on Zoom with your teacher. It's in the exercise sheets for this section, and that's where we'll do the proof. Okay. However, before we go to an example, I do want to make a little remark. And the remark is the following, is that we said the matrix is invertible if and only if AD minus BC is not 0. But that's the same as saying, and it's important to note that A is singular, so the opposite of invertible, if and only if that same expression, AD minus BC, is equal to 0. Okay, so saying that A is invertible if and only if AD minus BC is not 0 is equivalent to saying A is singular if and only if AD minus BC is 0. Okay, so keep that in mind, and we're going to use it in a minute. So let's see a little example of this formula. So let's scroll down to example 5.2.2. So the first one, the first question is simply find A inverse if possible. If possible means that we're going to check first, remember that AD minus BC, so 1 times 4 minus 2 times 3, we're going to check that this is not 0. So 4 minus 6, negative 2, and of course that is not 0, and therefore A is invertible. So you can just say A inverse exists, okay, which is the same thing as saying A is invertible. You don't need to write both statements, but I'm doing so just because for these first few examples, we want to get used to the terminology, right? So A inverse exists, or A is invertible. It's the same thing. And let's find that inverse matrix. So the formula was 1 over AD minus BC, but we computed that. It's minus 2, so 1 over minus 2, times the matrix. So we interchange positions for 1 and 4. So 4 here, 1 here. 2 and 3 don't move, but they take on the opposite sign. And therefore, we can give our answer as A inverse equals, and we can just multiply in, minus half, so minus 2, 1, 3 halves, and minus a half. And that is the matrix A inverse. And so we're pretty confident that this is correct. However, little note, if you do want to check that you have the right answer, you can, of course. So to check our answer, we can always multiply them, right? We can show that A times the matrix that we claim is the inverse is equal to I. Okay, so you can always check that this is correct by multiplying A inverse times your original matrix. Okay, and the second part of the example is find all real values so that the matrix is singular. So remember the remark from a minute ago? We said a matrix is singular, so you can here give it a name. Let's call it A. So we'll say A is singular. So we'll repeat the remark. If and only if AD minus BC is 0 this time, right? So we have 4 times 9 minus k times k. In other words, 36 minus k squared. And we want that to be 0. In other words, this quadratic equation we're simply going to solve it. Okay, right? 36 minus k squared equal to 0. Solve for k. It's a quadratic equation, but it's an easy one to solve. We don't even need to factor. We can simply say k squared equals 36, which means k equals plus or minus 6. And those are the two values, the two only values for which that matrix is singular. So always write a conclusion that uses the same wording as the question. So the question was find the values for which the matrix is singular. And so we'll say A is singular for k, we'll say equals minus 6 or 6. You can use a comma, you can write the word or, you can use set notation, k belongs to the set minus 6, 6, or you can even just use plus or minus. And we'll stop here for this video.